Okay, I hope we have no technical difficulties, but let me introduce Nathaniel Palmer, our keynote speaker, who is director at Serco in the USA. The title is Declarative AI at Scale, Powering a Robotic Workforce. And Mr. Palmer was previously rated as the #1 most influential thought leader in BPM, in business process management, by independent research, as well as one of the top 10 leading luminaries by Data Informed magazine. He frequently tops the lists of the most recognized names in his field and has been featured in media ranging from Fortune to the New York Times and a guest expert on National Public Radio. Nathaniel is a pioneer in the area of automation and digital transformation, very hot topics, having led the design for some of the industry's largest scale and most complex initiatives. He frequently tops the list of the most recognized names in this field and was the first individual named as laureate in workflow, as well as recipient of the Marvin L. Mannheim Award for significant contributions in the field of workflow. He's a regular speaker at leading forums and user groups and has co-authored over a dozen books on digital transformation, the X economy, intelligent adaptability, BPM everywhere, and so on, intelligent BPM, and so on. Also, Mastering the Unpredictable, which reached #2 on the Amazon.com bestsellers list, and his latest book, Gigatrends, to be published early 2024, defines the leading global trends affecting populations of 1 billion or more, each with greater than 1 trillion in economic impact. So this is about big things. Nathaniel.
Yes. Thank you. Thank you.
Please.
And I really need to update that. Bio was written by my late mother, and it is embarrassing with its immodesty. But thank you. I appreciate the chance to present here. And I know, looking at the agenda, I wish I was able to see more of the program. We had some travel difficulties getting in. But I know I'm standing on the shoulders of giants in terms of the presentations that have been made today, and I'm excited to share our story, and I'm hoping that you see the connection with our journey with declarative AI. But I wanted to start with a story, and you may have heard it recently. These two robots, they walk into a bar, and the first robot says, "I would like a cold glass of aquavit," but the bartender waves them off, dismisses, and says, "We don't serve robots." The other robot leans forward and says, "You will. Now, will we serve the robots, or will robots serve us?" And I would say the question is really a matter of, are the robots running on statistical AI or declarative AI? And this is a case study and a journey of, well, there were the robots, of a case study of my career over the last 8 years and how we've transformed a program, and one where the core, the center of gravity in that transformation is declarative AI. And would I be saying that if I were not at a conference about declarative AI? I may not have at the beginning of this, but we now understand that that's really what is the heart of this transformation. Now, the results are exciting and extraordinary, and what we've achieved from a business standpoint, but it's really what we learned in that I think is the most exciting, and that's really what I want to talk about today. But just to get you excited about what's behind these results, numbers like 500% efficiency gains. We were able to reduce operating costs by 2,000% or 20x. We've been able to show gains in how complex work is performed. So actually turning robots into caseworkers, doing complex casework, not just doing robotic things that robots normally do. And to talk about the problem space, it's one that may not be familiar outside of the US, because we have kind of a unique situation with health insurance. So the largest expenditure of the US government is on public health, We spend about $1.2 trillion, but that only covers 20% of the population. The other 80% either has no insurance or they get, which is the smaller part, and part of the population that this work was intended to address. But the rest get it through through private insurance. So in 2012, the Affordability Care Act, which is a shortening of the name, but what's informally known as Obamacare, was passed. And what that is it's the facilitation of the purchase of private insurance. So it's part of CMS, the Centers for Medicaid and Medicare. Medicaid is insurance for people that are below the federal poverty line. Medicare is for people that are over 65. But for those in the middle, there was no plan other than what exists today in the form of private health insurance. And the Affordability Care Act is to facilitate the purchase of that and provide a subsidy that's paid to the insurer, not to the individual. So an individual goes through and they get insurance either through a third party, meaning it's purchased either through a third party, but somehow it makes its way through the federally facilitated marketplace. And in the course of that, the cost of that insurance is reduced through what's called an annual premium tax credit, which is a benefit to that individual, meaning at the end of the year, they get a notice which said, your benefit from the government was this is what reduced the amount of the cost of your insurance, but that payment was made to the actual insurer. So along the way, how that happens is the individual attests to certain facts about what their income is, whether or not they're a citizen, other factors which determine their eligibility. And they are provisionally given insurance, but for the majority of them, that attestation has to be adjudicated. There's some mismatch between what the government has on record and what is the information that was presented. So the work that we do is adjudicating millions of those claims. And it's classic casework in that we have to gather tons of information, literally millions of documents, perform hundreds of millions of queries over the course of a year, and apply a set of rules to determine whether or not that individual can keep the insurance and the healthcare coverage that they already have, so that we're verifying their eligibility for what they've already been granted, but where the information doesn't back up what they stated, and we need to figure that out. So that has been a heavily laborious process. I joined in 2015. It was just a couple of years after the program had started to re-engineer what was already legacy systems, only a couple of years old, that couldn't keep pace with the changing requirements and the operational overhead for this program. And I knew that the way to do that was through the benefit of automation. The challenge was it was largely work that was not automatable at the time. So that journey from complex work that lacked definition to work that actually could be automated, that has been where we've seen these gains, and breaking that into effectively 3 epics with some overlap. But part of that was how I was able to sell the application of automation. The idea of automating work where we have a very critical outcome, which is not only providing or ensuring eligibility for insurance, but it's assuring that all the rules were applied. This is like a common thread, and the single biggest constraint is this notion of, but in government terms, is what's called program integrity. And it's that everybody has the same fair chance. Everybody gets the same shot. Same rules are being applied. So we can't use statistical AI. We could certainly do things with greater efficiency if we were able to make sweeping assumptions that way. But how could we then prove that the same rules were applied? And how can we demonstrate that, well, the robots are following the rules? When done right, human judgments actually the greatest inefficiency or the greatest cause of risk for not following the rules. But it's a scary thing for the government to accept that you can apply AI, that you can apply robotic capabilities, unless you're able to demonstrate that, in fact, the same rules are being applied. And so we began with a fairly simple problem space of just getting the information. So if you think about, going back to the general ConOps, that notion of ingestion, an intake, getting the information together, that when I joined the program was where the majority of time was spent. Then it was actually applying rules to that to understand. And in many cases, and when we began, it was applying a subjective interpretation of those rules, where we would train people to go and read policy documents, look at the information that's been gathered, and make a determination on what should the next step be, what should the outcome be. And then in the third area, where we don't have policy, where we have something that is not only an exception, but it's an exception for which there is no framework to understand how to correct it. That's this third area of research and resolution. And when I joined the program and I looked at this, and things weren't organized quite this way. I mean, this is part of a journey of understanding how things are done. I mean, there was a lot of complexity initially with things just, it's all just kind of in this chaotic space of casework for which there's no clearly defined workflows or process. But as I looked at that, I said, the only thing that a human being should do is that third column. But all of the time in the program, there's very little in the hours, which was measured in millions of hours per year to do this work. The vast, vast majority were spent in the first two. Very little time spent on the third, and very little time afforded to be able to do that. But that's really where humans should be focused. So to get there, we've gone through this process of first looking at how can we demonstrate capability around gathering that information. The second was to expand the distinction from the first was we're given the information and we're applying reasoning, rules, and automation to understand that information. The second is to go out and actually get it. So now that we have this information, let's set that down. So this second is that now that we have this information, we can start to figure out the things that we need to go get. We can start to log into government systems and get that information. And that was where the majority of time was spent the first few years that I was on the program. And then the third is actually performing the casework, doing what previously was exclusively done by humans, and then increasingly using robots to do that. So back to the result of that. One, we went from 5,500 people to just over 1,000 doing this work. The work was being done in 4 processing centers. We had to maintain a big part of that. We had to maintain the infrastructure to do this bulk burst of processing. The way that the U.S. insurance market operates, there's a window that's called open enrollment. And that's when individuals can enroll in new programs. So that's from the standpoint of adjudicating applications for insurance. It's hugely concentrated in the very beginning of that period of open enrollment, which begins the 1st of November, and then lasts. It's evolved over the course of this program, but now it lasts 45 days. And then there's the 90 days, and the 90 can be extended a little bit depending on circumstances. So there's roughly a 4.5, 5 month window where the vast majority of work is being done. And the way that the program had begun was we needed to maintain that capacity all year long. So we had the same facilities. We had the same IT infrastructure. We had mostly the same people, and that what we did have a seasonal aspect of bringing on new people, having trained those people, and then offboard them as quickly as possible. And that the speed with which we could do that, bring them on and offboard them, had a huge impact on the efficiency and the value of the program. But running counter to that is the accuracy of the work being performed by these individuals, where we're having to onboard them quickly and get them up to speed as fast as possible, where at the beginning of this, our ability to apply and enforce policy was largely around training these people and then looking at their work and performing quality assurance after the fact. You can imagine the inefficiency with that. The shift where we are today, we have no facilities. All the work's done remotely. There's 2 exceptions to that, but it's much smaller footprints over what was done previously. That burst of having to bring on new people with smoothed out significantly, and the way that the work is performed is now using for an expanding aperture declarative AI rather than subjective interpretation and training to be able to enforce those policies. And if you look at the bottom part of the slide, the shift from in terms of the nature of this work. So Serco is the company that's performing this work on behalf of the government worldwide. Serco does work that, from the standpoint of constituents and citizens, it would appear to be government work. The line between what we're doing and where the government begins and ends is very, very blurry. From a business standpoint, it's around the structure of and the type of the contract. So the work began as a cost plus fixed fee contract. All the risk was put on the government. However long it took us to perform that work, we got paid for the cost to do that. What is the biggest part of that cost is the labor cost of that, plus a negotiated fee, which is the margin for that work, which is relatively small. And that's kind of the nature of that sort of business. You don't make a lot of money, but it's done in large volumes. And there's no incentive there to be efficient about doing that work. The more efficient we were, the less we would get paid. So the only incentive is to be a good citizen. We shifted, and this was part of a vision that I can take credit for, and for me has been the greatest transformation of my own career. It was a shift from cost plus to fixed fee, where all of the risk is on the government, to a fixed price model and it's what's called a per unit fixed price. So we're doing work and being charged on a transactional basis. So we guarantee to the government that it's going to be cheaper, and it's going to be cheaper year over year. Whatever it costs us to perform that work, that's on us. And now, the first concern, particularly for a government customer where profitability isn't the primary concern, that notion of program integrity, the quality of the work, but more than anything else, being able to demonstrate consistency, that's what drives and overrides the notion of cost. So we introduced in that process levels of transparency, observability, SLA, service level agreements, and KPI, key performance indicators that hadn't existed before, because it was what it was. We had to demonstrate that we took that amount of time, but that was really all that mattered. In this case, we're now showing that we're performing that work at a greater consistency, higher quality, faster cycle time, cheaper cost, with substantially higher margins. So the work is far more profitable for Serco. It's cheaper to the government, cheaper to the taxpayer, and to the consumer. They have a better experience. So that has been the result of the transformation of this journey from a financial standpoint. But the rest of the story is about the problems that we solve to get there. And for me, that's the most exciting part of this journey, is to figure out how we could, well, it was figuring out how to do this And as a result, how we can do this elsewhere, how we can apply this to other things. And it required changing. And there was a perspective. I've used this same quote almost from the beginning. And what drove this in the beginning is different from how I would explain it today. What drove this notion in the beginning is that we had to change how we understood work and be able to separate the notion of who performs that work. Now, generally, processes in an operation like that, you would like to think the systems are built to support the workflows and the rules. In most cases, how the work gets done is conforming to the limitations of the systems and how they've been built. But you've got this tight coupling between the worker and the work that's being done. I had to break that tight coupling. Because if we were to convince the government that we would be automating this work, or be allowed to apply the level of automation that we would do, it would be very easy for the government to say, well, that's fine. So we'll pay you for the other work. The work that's been automated, why would we pay you for that? I mean, that you've automated that, there's no effort there. Well, now we've lost the whole incentive. So what would be the reason to do this to begin with? So this notion of making opaque by separating that notion of who performs the work, and instead be able to focus on the outcomes, including the quality of the work, the speed of the work, how the rules are being applied, what rules are being applied, changing the model so we have that level of observability to show that for every unit of work that's being performed, this is the outcome, this is the demonstration of why that outcome was achieved, what rules were applied, and who performed that work now becomes irrelevant. And that is the shift in our systems, where introducing automation and introducing a robotic workforce is looking and understanding the robots in terms of being workers rather than systems. Now, obviously, they are software, they're systems, it's IT, but it's having that distinction so that they're logging into the same systems. So whether it's a human worker or a robotic worker, the same rules are being applied, the same analytics are available. The outcome is the same. The actor in that is what's opaque. But allowing that to be possible is really the rest of the story, is being able to have a model where we can have robotic workers and human workers doing the same thing with the same systems. So a big part of that is using RPA, but also understanding how we use RPA, and that has evolved over time. But to begin talking about the role of RPA, and this is something that may be anathema to some of this audience. There are reasons to be skeptical or cynical about RPA, in particular, the way that it has been overhyped in the last several years. It's a very hot area from the standpoint of investment in the companies, investment in the actual software. RPA is now a very hot topic, and when we began this, it was just the beginning of that hype curve. But there are a lot of limitations to it. And fundamentally, it's that robots and robotic workers in the form of RPA are entirely deterministic. They can only do what they're taught. They can't make sense of things that are very basic for a human worker to do. Looking at a document and determining whether or not it is signed, and to do that with certainty. Now, you probably could use available generative AI to make an assessment, combined with machine learning, with machine vision, whether this is signed or not, you're not actually proving that it is. For a human being looking at it, it's easy to see, is it signed? Does it appear to be an appropriate signature? There's basic nuances that are very easy for a human being to do that are virtually impossible to program in a simple way with something like RPA. And that's one of the basic challenges of it. The model and the way that we create RPA in terms of the analysis and development tools that are available, it uses a workflow-like metaphor that looks not entirely dissimilar from that. Obviously, that's a sort of a cartoonish representation of a process model that can fit in a PowerPoint slide. But if you look at what is in the constructs of most RPA development, it's not too far off from that. And the problem is very little of our work looks like that. That's heavily focused on control flow. The ability to express within that business logic rules is virtually absent. And this, if you've come across this is a former colleague of mine, an analyst who's now generally known as the leading RPA analyst, Craig Leclerc from Forrester. He came up with this notion of 5 rules that there should not be, or the rule 5 rather, that there shouldn't be more than 5 decisions in any RPA construct. There should be no more than 5 apps that are involved and no more than 500 clicks. That fits the way a lot of the world is using RPA, creating what are basically fancy macros, not creating robots, not creating workers, but creating things to do, very discrete actions. But in any enterprise and in any operation, there is tons of opportunity. And we came up with one basic rule of thumb that at any moment where there's a user standing between 2 sets of data, that in itself is a robotic opportunity. But in order to be able to scale automation, to create robots that can actually do things beyond just being fancy macros, but to do real work, there's one thing that all robots require. And robots require rules. And in understanding that and re-looking what is really the design pattern for robots, understanding work not in terms of control flow, but in terms of outcomes, and being able to apply rules that determine the pathways rather than creating predetermined control-centric or sequencing-centric pathways. And doing that from the standpoint of applying human-centered design principles in a couple of ways. I'll talk about that more in detail. Again, no matter what, robots can only do and should only do what they are taught to do. You'll see it's more marketing positioning coming from the RPA community today, talking about the injection of generative AI and other capabilities, where now RPA is suggested to be able to do things that are beyond the scope of what it's pre-programmed to do. Well, I would lose my job if I built robots that behaved in that way. They can only behave in ways that we allow them to do. And ultimately, that is the limitation, but it's how we're able to expand the complexity of those instructions. That is ultimately what allows us to scale those robots. And there are certain things that became clear in doing this work. One is understanding how to respond to errors. And in our initial deployment, it was a simple pattern of we would stop that work, we would take the error and the work associated with it, put it back into a queue, and have that be reviewed by a human being. But that's obviously inefficient because that's happening quite a bit. So that ability to respond to slightly varying circumstances in terms of what's happening in the UI, or where there is something of an error that there could be a recovery, a predetermined remediation for, that becomes critical to the efficiency and scalability of the robots. And to be able to understand that in terms of what they can do and can't do. Because again, that sort of adaptability that's inherent in human nature and human capability and human behavior. We don't want to build that into robots, and it's in most cases very difficult to do that, but we can do that by interpreting the pathways that the robot's going to follow, and at what point they should be able to identify that they can't proceed, but to move that work forward with the context of what happened at that moment. And that's, we'll come back to later, talking about this notion of creating a dossier that the robot is constantly developing. But that pivot from having the declarative logic be part of the RPA construct to instead teaching robots how to follow instructions, not programming them with the instructions, but simply teaching them how to follow the instructions. We put it under a banner that we call Intelligent RPA, where we've created that separation. We're using at its core a decisioning engine, but that's also augmented with other capabilities where we're enabling the robots to do the same work as human beings. Both are now following the same set of instructions. And that was critical. And it was another serendipitous evolution where we actually was solving for a different problem. So as I was talking about at the beginning, this issue of having to scale up a workforce. And that was our biggest challenge, was being able to bring in, train, and then enforce quality through training, and basically telling our human beings to go, use this set of instructions and apply this, as in contrast with taking those instructions and converting that into declarative business logic. And those, certainly some of those online from the DecisionCAMP community, perhaps some in this room will recognize the construct. So this is a proprietary decision modeling notation. This is not DMN. It is not RuleML, but this is the decision model, which is still today evolves and is contemporaneous with DMN. At the time, DMN hadn't existed. We began this. In fact, that specific model was created in 2016. That was a snippet of the first one that we did, and that's is what we continue to use today. But the leverage point was in that transformation from having knowledge represented in a traditional way, but without lacking in any structure or any ability to easily translate it to a machine readable format, to putting those policies into a library of decision logic, which we could then enforce for our human workers to do things consistently, to be instructed on what rules to follow, to be able to demonstrate after the fact what rules were applied, and then to allow the robots to do the same thing. So it was probably a 3-year journey and leading up to being able to leverage this in the context of automation, where had we not done that, our ability to expand what we're doing from an automation standpoint would have been severely limited. This was the first key leverage point. The second, and also solving for a different problem space, was, and this is really our first foray into true declarative AI, where we had the problem space of work assignment. And that was particularly pronounced when we have 5,500 workers that are selecting the work that they can do. They're being rated on the quality of how they perform that work. And on one hand, they can be picking and choosing and saying, they'll look at work and say, oh, I don't want to do that because that's going to be complex. Or I could already see that there's problems with that. My score is going to go down, and I'm going to put that back in the queue. They could be doing things where there's switching costs involved that they are not factoring, where now their own setup to perform that work is in many cases more time spent than the work itself. And the next item of work that comes down the line, it's the same factor. The other is that, particularly when we have SLAs now, and we have issues where there are now rules and parameters which define how that work should be done, and the prioritization of that work. The way that was enforced previously was we had supervisors walking around with clipboards and saying, hey, I want you working on this. You need to be working there. They're getting the call down from operations on what they should be doing. So all of those things were hugely inefficient even before entering robots into the mix. So solving for that issue and coming up with something that we call dynamic work assignment, with solving the basic issue of the right task for the right worker at the right moment in time. Well, all of those rights are decisions for which there's decision logic. What is defining what's right? Well, it's at a moment in time. It's what are our SLA targets? What is the queue that we have, and how does that queue affect our SLA targets? What is being worked on? What is the capacity in aggregate of our workers based on, at that moment, the factors we have in our HR database? There's multiple repositories where we're looking at the parameters for what defines for that worker, what should they be working on next, and to do that within a fraction of a second so that work is coming to them. Now, having solved for that, and that was critical to the efficiency gains that we realized, but now we can actually bring in robots into the mix where we couldn't previously, using the same pattern. These robots are workers. This is not a system integration. This is a robot performing work just the same as their human coworkers. So we assign that work that way. And then in that assignment, the first aspect of that is to determine, well, is that work that's appropriate for a robot? The design pattern and principle here is that everything should be appropriate for a robot in a broad sense, but every unit of work has nuances and certain characteristics which mean that at that moment in time, and this is something that we evolve, but at that moment in time, we may not have the means for the robot to do that work. So we won't know that until the robot's performing the work in most cases. There are certain factors where we can say, robot's not going to perform this work. Today, and this will change for sure, today a robot can't place a phone call. So if that work is going to involve placing a phone call, we're not going to assign that work to a robot. But there are other nuances where until that work is performed, we don't know if it's appropriate or not. But it's pretty cheap for the robot to take that work, look at it, and start to work on it and say, you know what, I can't finish this, or I can do this and this, but somebody else is going to have to do the rest. So I'm going to put it back into the queue with an understanding of this work's been performed. And the next person that receives it doesn't have to redo that work. And that doesn't just apply to robots, because the spectrum of work that we do, even though we've reduced from 5,500 down to just over 1,000, there's still areas of specialization that don't expose themselves until you begin that work. And that is expensive for human beings to receive that work, start working on it, realize that they can't complete this work. They've got to put it back into a queue. And every moment that they spent on it is non-billable. In the old day, it didn't matter. However long it took us to perform that work, that's what we got paid. Now we only get performed when you complete that work. And if somebody's working on that work and not able to do any meaningful progress on that work, well, that's money lost. So why not have the robots do that and take every unit of work, whether or not it's what we deem robot appropriate, unless it's clearly not. I mean, we don't have them looking at stuff where it's just a phone call. But for other aspects of complex casework, the robot will act on it, even if it can't perform meaningful work on it. What it can do is determine what are the factors around that work that are ultimately required for this work to be completed. Put that back into a queue with that understanding, rather than having a human being perform that. That was one of the more recent innovations that we've done, and it's something where it had a huge effect initially, and it still has a very positive effect. One of the unintended circumstances was now where we had that kind of screening of humans that were doing work, and we weren't escalating. The robots were escalating work to the higher paid work class legitimately, but in a large scale. So our government customer said, wait a minute, all of a sudden you went from work that kind of looked like this, where there's lots of activity here, this kind of low value work. Now it's all high value work. We say, yeah, well, so the robots are doing all of that low value work. And now we had to prove that the concentration of high value work really is what it is. And for the short term, we kind of split the difference and said, well, this has an increase in billing. From our standpoint, it's an enormous increase in the efficiency, because we're not spending time over here. It's the robots that really don't cost us. I mean, that's obviously there is an economic cost for robot work, but it's a fraction of human work. So initially we split that difference, but it's also part of the evolution of that work to understand that we're going to be increasingly using a robotic workforce to perform that lower value work, but what was previously that long tail of the majority of the workforce that was lower cost, lower wage, doing that work, that's now all going to be done by robots. And the truly complex case work, the real knowledge work, that's where our humans are going to focus. So being able to find that distinction at any given moment in time, we're chasing the notion of, is this work that a robot should be able to perform, or are we telling it prematurely to stop, put it back in the queue, and don't perform it? We're always erring on the side of that, because we can't err on the other side to say, hey, robot, give it a shot, whatever the outcome, we'll figure it out later. There might be some scenarios where you can do that, but when you're talking about things of performing on behalf of the government, the function of validating eligibility for healthcare, the need for precision to demonstrate that the rules were followed, that this received the highest quality touch, we have to err on the side of, if there's any shadow of a doubt whether or not we can perform that with our robotic workforce, we have to err on the side of putting that into a queue. So we're constantly chasing that notion of figuring out through literally hundreds of thousands to millions of permutations of different instances and circumstances around that work. So in the beginning, it was very easy. We go after, just clearly defined, very discrete parameters around the low-hanging fruit. And we were able to demonstrate value pretty quickly because there was a lot of that work. As we get into increasingly complex work, that's where that nuance becomes critical. So one of the first things we did is, and this is now a constant thing. In fact, I was speaking just 2 weeks ago at another conference, and somebody who came from the academic community talked about process mining, which as a discipline evolved not too far from here in the Netherlands, and now has become a real thing. It is now its own industry, and there's a mature set of capabilities there. But the way it was positioned is, this is kind of upfront work that you might do once and not do again. And that's why companies like Celonis and others that have now become large players in the space, why they're going to have challenges, is because it's kind of a once and done thing. And I say, well, that's not true at all. We're using this continuously and constantly, evaluating every piece of work for two factors. One is to prioritize because we still have to do quality assurance. From a contract standpoint, it's 5% of every item of work. And the way that's done still largely, and certainly the way it was done 2 years ago, and from beginning of time and until 2 years ago, was through randomization. So we're just statistically assuming that the work that we're looking at is representative, as opposed to using process mining to be able to identify what is working. If we can prove within a series of confidence intervals that that work was absolutely consistent. Why would we need to look at that to evaluate its accuracy? And that's one of the challenges of this kind of adjudication work, is it's about how the work was performed, not the outcome in terms of was the determination in favor of the consumer seeking healthcare or not. It's were the rules followed appropriately. And if we can demonstrate that all the rules were followed appropriately, and we have that in an observable analytical format, we don't need to look at that work. But there's this whole other spectrum of work where there is some question around that, and we can identify that using process mining. And in the course of that, also start to create parameters that we can now use to expand the declarative rules and figure out what is the type of work that robots can do to completion. So that aspect has been critical to expanding the aperture for the work that we're doing. The other is creating this concept, which I've actually not seen anywhere else applied in industry, and it's not something you get from the platforms that are used to create these capabilities. But it's this notion of a dossier, making that work observable, where in the initial capabilities, even where we're telling the robot that under these circumstances, discontinue, return that work back to the queue. But why? What was it about that work? And we could have a code. I mean, we could, since we're talking about millions of tasks, it's something that has to be broken down into, with some type of parameters. But why was it that work was done? And that isn't an inherent part of any of the platforms. It's not necessarily part of most automation design platforms. That notion of creating the dossier and using that to continuously evolve what they're doing, that was one of the key innovations for us, and it's one that's evergreen, and that I don't think you'll ever get it right. You're going to be constantly expanding and refining and figuring out more and more about that. To the extent that we've created robots to do that work. So our pattern for introducing robots into the environment, and this is not unique to us. I mean, this notion of attended and unattended, which is the next slide, that's commonplace. And this for machine learning, for RPA, attended and unattended, I mean, everybody has this basic notion. For us, what it has meant is creating and understanding basically robots as a service and creating special parameters around that so that we can call at the right moment in time. The majority of work that we're doing, and the majority of RPA work that I've seen in the industry, is on this side of it. It's initiated by a human, and in this case, it's almost exclusively initiated by other robots. But where industry-wide, where I've seen typically is that this is the majority of how RPA has been deployed. For us, this is supporting the work being done by the unattended robots who are logging into the system and doing work just like any other worker. And again, that's because we've created this capability with the dynamic work assignment and other things where we've taken the approach that our robots are workers, even if there are specialized robots that do work just to support those robots. Our robots are workers just like anything else. So when I have talked on panels and had other opportunities to compare results, everybody brags about their hundreds of robots, their thousands of robots. Those aren't robots. Those are macros. We have maybe a dozen at most that fall into these basic categories. And the majority now, that the third one is the majority of the work by design, and that's our goal, is that we can have a robot worker that's able to do end-to-end, that's supported by different querying capabilities. And earlier I talked about, we're performing tens of millions to hundreds of millions of very complex queries where we're going in, getting information, looking at the context of it, applying rules and policies to understanding that context, taking that context, performing more queries, taking that result, comparing the two, doing things like trying to figure out fairly what seems simple, but is actually relatively complex concepts around the notion of determining what is the actual income that's going to be earned by an individual in the period of the coverage of their health care based on the limited information that they've provided within the context of how the government calculates that. These are all things that would seem fairly mature and standard, but they're actually quite immature and pretty nebulous, particularly in the context of healthcare eligibility. In mortgage processing, there are more mature but also loose categories there by design, that underwriters want the freedom to be able to say, well, we can get this through, don't worry about it. We can't do that here, and we need to have that consistency, and it has to be within an explicit declarative framework that is virtually impossible to apply without having the layers of rules and around things where we're performing queries that are a lot more complex than just normal automated queries or stored procedure type queries. So that's where we have a specialized fleet of robots that are doing that work. There are other areas where they're doing facilitation and getting information, either feeding into that but ultimately feeding into the worker. And then the last being the robot dossier, where a robot is creating the dossier and tracking that dossier for the work that's being done by robots. So looking at this in terms of the ecosystem that we have, and when I joined the program and we went down to, we had a very workflow-centric view of this work. We kind of understood it as case management. I joined this program as I saw it as the most complex case management scenario or opportunity that I would have in my career. And at that point in my career, that was where I was focused. But all of that assumes a chronological sequence and a control flow around the sequencing. That's not really how this work is being performed. And that's where I say that declarative logic is what is ultimately at the center of gravity here. It's driving everything from how work is assigned, how that work is performed, being able to take that in and bringing into the dossier, being able to make the connection between why wasn't a robot able to complete this work? What are the nuances that we can fix, that we can bring into and refine the models, using machine learning to do things around classification of documents and data, how we extract that information, but not making decisions, so that every outcome and every determination follows the same rules. Those rules are observable, they're reportable, they're part of the dossier, but they're also part of that case record and how that work is being performed. And to be able to continue this in a cycle where we're expanding more and more, so that we go from 7% to today around 25% of the most complex work being performed by the robotic workforce, to in the near term having only the most complex work, and that where we're doing facilitation with consumers, where it's interaction centric as opposed to transactional and production centric. So that we're just on the cusp of that, and it's an absolute shift from just a few years ago, at most 5 years ago, which is a blink in the context of government programs, where the vast majority of the work was around that transactional work of getting information, analyzing it, and making very mundane decisions, to getting to the point where we're doing true, what we call white glove type interaction with consumers. So we're just about there, and I'm just about done. I want to close with one point now, and this is closing on a positive, not on a down note, but what, particularly as an American, 9/11, which the anniversary was last week, it's top of mind for many in the world, and including Americans. And I the result of what happened is not necessarily something that I agree with from a policy standpoint, but that common experience of, where were you when you heard about this? In my case, I was on a conference call with clients. We'd had a meeting canceled, and this becomes relevant in a minute. So we repurposed the time for that meeting to have a conference call to talk about why the meeting was canceled and where we go from there. Colleague pops his head in my door and says, "Hey, a plane just flew into the World Trade Center." I said, I had this image of like a Cessna stuck to the side of the World Trade Center, thinking, God, that's tragic, but that poor pilot must have been, maybe a student pilot or something, what's gone wrong? So he says, "Yeah, it's on TV." So, also that period of time, for some reason, everybody had a flat screen in their lobby with CNN running 24/7. And so I went into the lobby and looked at it and could see the building, smoke coming from the building. And just that instant when the second plane hit, and still naively, I was thinking, wow, our air control system must be completely, off the grid. And then it became obvious, this is an attack, and it became a solemn, angering. I mean, everybody went through a complex set of emotions, and it honestly wasn't until 2 weeks later that I realized the meeting that we were to have had, that we'd repurposed, and that because it was canceled, was actually at Morgan Stanley on the top of the World Trade Center building. And once I realized that, I said, my God, that is pretty remarkable. And for at least a few years, I thought, well, had it not been for that meeting being canceled, and it was a Morgan Stanley was going to be investing in a software company who was a client of mine, and around that time, unrelated, although accelerated by the circumstances of 9/11, the investment market was starting to unravel and meetings were being canceled. And I thought, wow, thank God that the .com bust saved my life. But I would have been okay. I uniquely would have been okay at a Morgan Stanley meeting, because of the 2,707 people that were in the Morgan Stanley office, 2,700 survived because of this man. And what was going on in that moment in the buildings and the way that the Port Authority was handling it. There's a whole case study. I mean, there's multiple case studies. And I just on this trip was even rereading the 9/11 report and seeing the case study around bad decision-making that was made. There was analytical latency. There was confirmation bias. There's every aspect of decision-making gone wrong that happened there. There was one exception, which with Rick Friscola, who is the director of security for Morgan Stanley, he had survived the 1993 bombing. And a lot of the policy was framed around the 1993 bombing, but it was based on something that was the exact opposite, a bomb in the basement as opposed to a plane at the top of the building. He had determined and came up with a set of declarative rules, and against all other policy, enforce those rules. Now, it may seem like a stretch to connect it to decisioning, declarative AI, but it's closer than you would think. And in fact, every single person under his care survived. The 6 people that refused to go with him, 2,700, follow the rules that he had put in place and that he ensured were followed against the Port Authority, against first responders and everybody else. All of them survived. A survival rate unparalleled by any other part of the building. 6 people refused and they perished, and unfortunately he did too. He went back in to try and coax them out, and that's when the buildings collapsed. But in that case, rules, declarative decisioning, save those lives. And I think it's apropos to remember so close to the anniversary. I'm going to stop there. Thank you.